For the vast majority of human history, the concept of private property was practically non-existent. Nomadic bands carried only what they could physically transport, relying on communal sharing rather than individual hoarding to survive. The advent of agriculture introduced a new phenomenon to the human experience: the physical surplus. For the first time, humans possessed more grain, tools, and wealth than they could use immediately. As these early settlements grew into proto-cities, the centralized wealth of the harvest became a target. The increasing density of populations created social friction, and the unequal distribution of successful harvests gave birth to the concept of theft. Before mechanical locks, security relied entirely on physical presence. The economic burden of employing human sentries was immense, restricting the accumulation of wealth to monarchs or high priests who could afford constant guards. To allow individuals to leave their property unattended, society needed a way to substitute human vigilance with physical engineering. The lock emerged as a required tool for this transition, providing the mechanical security necessary for private territories to exist within growing cities. The archaeological record points to the ancient Near East as the cradle of this engineering. Empires in Mesopotamia and Egypt, possessing vast trade networks and royal storehouses, required a dependable method to secure their assets. We see the scale of this need in the monumental ruins of Dur-Sharrukin, the massive Assyrian capital built for King Sargon II. Within these palace walls, archaeologists discovered the remains of a highly sophisticated wooden security device. This Assyrian invention was a brilliant precursor to modern design. It utilized a heavy wooden crossbar held in place by loose wooden pins, which dropped into corresponding holes to physically prevent the bolt from being withdrawn. To unlock it, the user inserted a paddle-shaped key fitted with upward-facing pegs. When lifted, the key pushed the gravity-fed pins out of the bolt, removing the obstruction and allowing the crossbar to slide freely. For the first time, a door could be secured from the outside. Human access had been successfully converted into a mechanical code, granting owners absolute control over their domain. These early wooden locks were restricted by their materials. Cedar and oak are accessible, but they remain susceptible to rot, fire, and moisture expansion, making them vulnerable to both the elements and brute force. Roman engineers transitioned these concepts into the realm of metallurgy. By mastering iron and bronze, they moved away from bulky wooden installations toward refined, compact devices with significantly stronger internal components. This material shift enabled miniaturization. For the first time, high-level security became portable, allowing Romans to manufacture small padlocks and lockboxes to protect personal jewelry and sensitive documents. As locks shrunk, they became wearable items of prestige. Affluent Romans fashioned keys into ornate rings, wearing them visibly on their fingers as jewelry. To wear a key was to make a public declaration: "I possess things of such value that they must be locked away, and I alone hold the power of access." By transitioning security from massive wooden beams to personal metal items, the Roman era established portable security as a defining hallmark of individual prosperity. During the 19th century, industrial urbanization clustered massive populations in cities like London and New York. The booming middle class demanded reliable, mass-produced security. The era introduced precision-machined steel cylinder locks. Because of the extreme manufacturing tolerances achieved by inventors like Joseph Bramah, the British public believed they had finally achieved perfect security. Inside these cylinders, pins block the mechanism from rotating. A key lifts each pin, creating a shear line to remove the obstruction. But in 1851, Alfred Hobbs shattered this illusion. By mapping microscopic mathematical tolerances, he picked the unpickable locks, proving no barrier was invincible. This high-profile failure drove the industry toward constant, iterative improvement. It resulted in Linus Yale Jr.'s invention of the small, flat key with serrated edges, a form factor remaining the global standard today. The arms race between precision manufacturing and the breaker mindset ensured that the lock would continue to evolve as a mechanical processor of codes. The late 20th century replaced the physical key with digital credentials. However, early wireless systems merely shifted the target. Intruders began exploiting software and network signals rather than manipulating brass pins. As of 2026, the Aliro 1.0 standard has introduced a unified protocol for smartphones and wearables. Using ultra-wideband technology, these devices act as universal keys, allowing for rapid, point-to-point verification that functions independently of the cloud. Biometrics have moved beyond surface-level prints to vein recognition. By using infrared light to map the unique internal blood vessel patterns beneath the skin, these systems verify the living tissue of the owner. Because this process scans internal patterns rather than a surface image, it is highly resistant to spoofing efforts like high-resolution photographs or silicone molds. Yet for all the AI processing and deep tissue scanning, the core of the system remains a 4,000-year-old mechanical concept, a heavy, physical deadbolt that prevents the door from moving. Our journey through material science has come full circle. The lock hasn't been eliminated. It has simply integrated our own biological tissue as a physical enforcer of privacy.